Hi everyone, my name is Abdulrahman Alhamali. You can call me Abd for short. And this is my cat, Anouf. And we're going to be talking about how to basically use service discovery cowboy shenanigans to make running a game day a little bit easier. Before we get into that, for those of you who don't know Shopify, we are an 8,000 plus employee company, and we are an e-commerce platform that runs the shops of millions of merchants in 175 countries worldwide. Just last quarter, we had achieved a new milestone of $1 trillion running through our platforms, basically. And last Black Friday, in one weekend, we conducted $11.5 billion of GMV. We saw an average traffic of 170 million RPM, and it peaked at 280 million. That said, we have a resiliency team. So this is a subset of the team. Right now it has grown a little bit more. So we have 40 SRE engineers that are part of the resiliency organization. We have a resiliency organization that has our team, another team that we call the RAT team, which is more resiliency acceleration tooling team. And then we have also incident response, which are more responsible for communicating with merchants and support during incidents. Our team specifically, we're basically responsible for everything resiliency. So from anything that has the word incident in it, it matters to us. From testing to improving the product, again, like we said, to education, to actual incident management. We have a follow the sun team. Some of us are in Australia, Singapore, I'm in Canada, and we are basically the first responders whenever anything bad happens. And lo and behold, bad things do happen. And as some might argue that the best way to test your resiliency for incidents is to wait for them to happen and wait for surprises to learn from them, ideally, you do that in a little more controlled manner, which is what game days are for. So for those of you who don't know, in a game day, the way we do it, at least in Shopify, we start by creating a thing we call resiliency matrix. So you go and you kind of list the flaws that your service has, and then you go to the possible faults that can happen, and for every one of them, you say what you expect the reaction or like the effect on that flow to be. Is it gonna be down? Is it expected to be able to survive this specific thing? Is it going to be maybe prioritized or shed, etc.? And then you go and you inject the fault, basically. So yeah, game days are about simulating incidents, and our team specifically, we run the larger scale, more crafty game days, but we also want teams to be responsible for their own smaller game days. So we want everyone in our organization to be game daying all the time. And that's at least we ask them, like, okay, make a resiliency matrix and tell us what's gonna happen to your flows when your dependencies are down. Surprisingly, a lot of teams don't even know what their dependencies are, so the exercise is already useful. That said, once they have listed that, we wanna start injecting faults. The question becomes whether you should actually shut off the dependency to simulate the failure. A lot of our SREs would tell you yes, and a lot of them would shudder in fear of the idea. And the answer is probably somewhere in the middle. Like, especially for team-specific run game days, the ones that SREs are not run, we want to make them easy, we want to make them a little bit more controlled, and we want them to be a little more abstracted. So they're running their own game day. We don't want to affect other services, and also we want it to be a little bit abstract for them. Like, from the client's perspective, the service is down. It doesn't matter if the service is actually down, or if it's a networking problem, or if it's a security problem. Typically, for application developers, for them, it's down. So with that in mind, what we do to simulate that, we use fault injection proxies. The two most common ones we use, or pretty much the only ones we use, Toxi Proxy and Envoy. Toxi Proxy is an open source one that we developed in Shopify. The nice thing about it is that it has client integrations. So it sits, like if you also want to put it in your CI, it sits perfectly in there. You can basically write a test that says, okay, take the dependency down and run this code and then do a little bit of assertions. So it works great in CI. But also, obviously, you can use it in a normal game day. And then there's Envoy. The nice thing about Envoy is that chances are you might already be using it in production, so you can just add a little bit of fault injection in there. You don't need to install anything. But if you're not using Envoy already, if you have to put that proxy, the challenge becomes about like, okay, how do you actually get the traffic to go through the proxy? Because the proxy is going to sit in the middle before your dependency, and you want to figure out what to do. It's easy, right? You kind of just change the code. So instead of saying I want the traffic to go to database 1, you say I want the traffic to go to Toxi proxy, right? And you can do it in your code, you can do it in configuration files, and then you just generate a different image and put it in your production. And this is very quickly starting to sound like a bad idea. Yeah, we don't want teams having to mess with their service and with their code and with their configuration files just to run a game day. Ideally, for us, the game day is something you kind of plug in, you run a bunch of tests, and then you remove, and everything goes back to normal. Once we start talking about like, okay, you gotta change your code and push a different image, then something is wrong. So yeah, we don't wanna add this friction. It's dangerous, it's not safe, and it's gonna make them do it less often. Instead, what we provided was something we call the game day buddy. So this is a Kubernetes operator, and this is an example of a sample configuration. We call it a game day config. So in it, you can kind of, you provide the name of your service, which deployments you're targeting, which dependencies you're trying to game day, what kind of toxics you're trying to inject. So for example, you want a latency of 1,000 milliseconds, and that's about it. It does the whole thing for you. Basically, yeah, like it spins up Toxi proxy and it directs the traffic through Toxi proxy for you. The question is, how does it do that? And for that, there's a lot of nuance as well. So in general, and here we're gonna get a little bit more meta, we do it with 3 approaches that I think in general, when you're hijacking, you can do any of that. You can either change locally or globally or on the way. And we're gonna give 3 examples because we support all of that. So the most straightforward one is locally. Basically, we change the client itself to be like, instead of talking here, talk there. So in general, for those of you who don't know, when a service is trying to do DNS resolution, before going to the DNS server, it might check the etc host file to see if there are any entries in there. And if it finds entries in there, these are overrides. And the nice thing is that Kubernetes allows you to provide a field called host aliases that you can add those entries in it. So basically, like the way Game Day Buddy works, and by the way, I use a lot of sequence diagrams. This is the segue, but like if you don't use sequence diagrams, please do. They're amazing. But yeah, like basically it spins up a Toxi proxy, and then it talks to the Kubernetes API. It says, please add host aliases to direct the traffic to Toxi proxy. And it also instructs Toxi proxy to talk to the actual upstream. And now you have it in the middle. That's perfect. Very straightforward, very easy, except if they do one small thing, which is put a dot at the end of the domain name. If they do that, their service decides that, okay, I don't want to look at the etc host file anymore. I'm just going to go and I'm going to talk to the DNS. That's an optimization. It's useful for them. It's not useful for us. So then some of the 2 other approaches becomes needed, which is like, fuck it, I'm just going to go, I'm going to change the whole rule globally in the DNS server itself, and I'm going to add an entry saying, if anyone is trying to talk to Redis, I want it to talk to Toxi proxy instead. This is getting a little bit icky. We use it sometimes under certain conditions. It's like, okay, if the core DNS maybe is only configured for the namespace, or if it's like a cluster that we spun up for testing, we can tolerate something more global in there. That's not an issue. But for the majority of cases, this is an issue. And for us, Zookeeper was the big one. And this is basically where we're getting into more nitty-gritty service discovery. So the way our different services, basically, the way they discover a lot of things, like if you're doing Vitess, if you're doing caching, very often the service doesn't exactly know what dependencies exist in the first place. So it doesn't use DNS to do that, to discover them. Instead, one example technology is Zookeeper. So the way it does it, it knows where Zookeeper is, thankfully. It starts asking it questions, like it starts sending a bunch of list requests, basically. So if you, for example, have memcached, there's many partitions, it's broken down over different domains, etc. The client kind of knows what domains exist, and it just starts inquiring Zookeeper about what zones exist, what regions exist, and how many partitions exist. And Zookeeper basically responds with, first of all, it sends a bunch of lists, but then it says get for a specific one of them. This is the one that it actually wants to talk to. And Zookeeper is going to send whatever information you stored in there. So that could be the IP of the upstream. It could also be like a lot of other information. Like if it's a database, is this a writer or a reader? What's the replication like, etc. And then it can finally talk to the upstream. And Zookeeper for us is global. We can also kind of do like what we did with Core DNS, and we can just go and change the content of the node to whatever we want it to be. But instead, we do it on the way by using something we developed called Zoocreeper. So Zoocreeper is yet another proxy that we use. And it sits basically between the client and Zookeeper. So whenever the client is doing all the list requests to Zookeeper, Zoocreeper just forwards them. It doesn't care much about them. But the moment it sends a GET request, this is the meaty one. This is the one that actually has the node information. So it actually forwards the request to Zookeeper, which sends back the true information. But before forwarding it back to the client, under the hood, it creates a Toxi proxy, and then it puts the IP of Toxi proxy in there and sends back to the client. And now the client is going to talk to the upstream using Toxi proxy. So it is, in general, we're always kind of doing the same thing. We're figuring out, like, how is this service talking to its dependencies? How is this service discovering its dependencies? And we're basically hijacking this discovery layer to forward things to Toxi proxy instead. Zoocreeper is not yet open source. I'm hoping one day I can open source it. It's pretty nice. We're proud of it because, like, first of all, it talks the Zookeeper communication protocol. And for those of you who don't know, this is not actually documented. Like, I had to actually, like, I found some other Zookeeper clients and I had to steal some code from there, and like, eventually we figured out the communication protocol, plus a lot of Wireshark stuff. The second nice thing is that, like, this content in here, it could be a JSON. If it's Vitess, it could be like a protobuf encoded blob. It could be anything, basically. So Zoocreeper was developed in a way that is pluggable. Like, whatever new protocol you want it to talk, you just add a plugin, a few lines of code, and now it supports that new protocol. So we use it for 3 different protocols in Shopify so far, and hopefully we can add a few more later. And yeah, the nice thing about it also is that when it comes to discovery, like, especially when you're discovering things with Zoocreeper, you can get it to override just one dependency if you're just trying to hijack one dependency. But you can be like, hey, I want it to not be able to talk to all of US Central 1. So for Vitess, for example, we once conducted an experiment and we told it, like, hey, anything in any database that exists in US Central 1, I don't want it to be able to talk to anymore. And it was like just a single line of configuration, which was very easy for developers to do. So yeah, in summary, First of all, if you're not running game days and if you're not making your teams run game days, please do. They're very important. They're very easy. You can even run them as a tabletop exercise. Just get them to do the resiliency matrix. That's already a huge step. But yeah, if you want them to run proper game days and to run them frequently and effectively, they need tooling. And one obstacle that we found often was that, okay, how do we override things? And we did it at the service discovery level, locally, globally, and on the way. And that's it. Thank you.